Today's video is going to be about factoring trinomials where a equals 1. So to warm up, we are going to multiply some binomials together to see what kind of trinomials we get. X times x is x squared. X times 5 is positive 5x. 1 times x is positive x. And 1 times 5 is positive 5. When we combine like terms, these two are like, so they will combine, and we will get x squared plus 6x plus 5. Let's look at the second example. M times m is m squared. M times 6 is positive 6m. Negative 4 times m is negative 4m. And negative 4 plus or times 6 is negative 24. When we combine the two middle terms, we are going to get m squared plus 2m minus 24. For the last example, k times k is k squared. K times negative 3 is negative 3k. Negative 7 times k is negative 7k. And negative 7 times negative 3 is positive 21. When we combine like terms, we're going to get k squared minus 10k plus 21. So it says trinomials like these can be factored into a product of binomials. So if you look, standard form of a quadratic trinomial is ax squared plus bx plus c. This a term is missing from all of these because a is just equal to 1. That is the type of thing we are learning to factor today. I want you to look back now at the pattern that happens here. If we look at what we started with here, and we look at this number and this number, positive 1 and positive 5. If we add positive 1 and positive 5, we get positive 6. If we multiply positive 1 and positive 5, we get positive 5. And that pattern is going to continue. If we add negative 4 and positive 6, we get positive 2. If we multiply negative 4 and positive 6, we get negative 24. If we add negative 7 and negative 3, we get negative 10. If we multiply those numbers, we get positive 21. This is going to help us to go backwards from here to here. So if we want to factor a trinomial of the form x squared plus bx plus c, meaning that a equals 1, because a doesn't have to be written down then, you must find two integers that multiply to get c and add to get b. For example, what two integers have a product of 12 and a sum of 7? I always start with the product, and I list the the factors of 12. So the factors of 12 are 1 times 12, 2 times 6, and 3 times 4. That's all of them. So which pair add up to get 7? The only pair that does that is 3 and 4. So we have 3 and 4 here. So to write two binomials using these integers, we are going to, they're positive 3 and positive 4. So we're going to have x plus 3 and x plus 4. Then, to check our answer, we distribute. X times x is x squared. X times 4 is positive 4x. 3 times x is positive 3x, and 3 times 4 is 12. So we're going to get x squared plus 7x plus 12, which is the correct answer. Is the correct problem that we started with. So that means this is our correct answer. So on your paper, you're going to see that these are broken down into sets. There's set 1, set 2, set 3, set 4, some mixed practice, and some greatest common factor practice. So the reason these are broken into sets is because they have different signs. For example, this is positive and this is positive. In the other sets, you will see a different combination of positives and negatives. For now, let's focus on what we just learned. This trinomial is going to factor into something that looks like this. And we're going to assume that these are both positive, and we'll look into why in a few minutes. But we know that these are both going to be n because that's what it told us. in the rule, and we want to find a number that multiplies, or two numbers that multiply to get 20 and add to get 9. So the numbers that multiply to get 20 are 1 times 20, 2 times 10, 3, and I'm testing 1, 2, 3, 4, 5, etc. 3 does not go into 20 evenly. 4 and 5 can be multiplied together. And then my next number I would test would be 5, but I already have 5 on my list. So if you test every integer along the way and then you start to repeat yourself, that means you have all of the possible combinations. So which two of these add to get 9? 4 and 5. So 4 and 5 will go here. Now we want to check our answer. So n times n is n squared, n times 5 is positive 5n. 4 times n is 4n, and 4 times 5 is positive 20. When we combine like terms, we get n squared plus 9n plus 20, which is the same thing we started with. So that means this is the correct answer. If we take a look at number 3, we know that we're going to set up our binomials like this. And we just have to find the two numbers that go here. So the factors of 24 are 1 times 24, 2 times 12. I'm going to pause here and explain something. If you're trying to do this in your calculator because you're not great at mental math, you would do 24 divided by 1, and that would give you 24. 24 divided by 2 gives you 12. 24 divided by 3 gives you 8. 24 divided by 4 gives you 6. And 24 divided by 5 would give you a decimal, so we don't get to write that one down. Then we would test 24 divided by 6, but oh wait, 6 is already on our list. That means we have all the factors of 24, and these are our only choices. So we want to find which two add up to 10. 4 and 6 are the only option that add up to 10, so we will put 4 and 6 here. The order of these does not matter since both signs are the same. Now we want to check our answer by distributing or using the FOIL method. A times A is A squared. A times 6 is 6A. 4 times A is 4A, and 4 times 6 is 24. So when we combine like terms, we get A squared plus 10A plus 24. That is in fact what we started with, so this is the correct answer. Now we're going to talk a little bit about what happens when we have different signs. So we know that our terms will definitely be binomials, and they'll definitely start with n because n times n is the only way to get n squared. But it's not always going to be positive positive. In this case, we need to multiply to get negative 18. So the only way we can multiply to get negative 18, if we go somewhere on the side of your paper, a positive times a positive equals a positive. A positive times a negative equals a negative, and a negative times a negative equals a positive. So the only possible choice, if we need to multiply two numbers to get a negative answer, is to multiply a positive and a negative number. So in my binomials, I'm going to put 1 plus and 1 minus. Now, the order of your plus and minus do not matter, but the number you choose to put with the plus and with the minus does matter, and we'll look at that as we go. So we want to multiply to get 18 and add to get 3. This sounds a little funny because if you add two numbers to get 3, they're not big enough to get 18. However, when you add a positive and a negative, for example, if we had 3 plus negative 2, we get 1, which is actually the difference of the numbers. So an easy way to remember this is if you have different signs, so a positive and negative, if you have different signs, you want the difference of the factors to equal the middle number, or B. If you have the same signs, you want the sum of the numbers to equal 3, or to equal B. So we have different signs, so we're looking for factors of 18 that have a difference of 3. So we have 1 times 18, 2 times 9, 3 times 6, 4 doesn't go, 5 doesn't go, 6 is my next number, but it's already on the list. That means we're done. So this has a difference of 17, this has a difference of 7, and this has a difference of 3. So that's our choice. Now, we have to look and see if we need positive 6 plus negative 3 or negative 6 plus positive 3. So this will give us positive 3. This will give us negative 3. We need our answer to be positive 3, so we're going to choose positive 6 and negative 3. So the pattern that this is going to follow to help you remember is that the bigger of your two factors, so in this case 6, is always going to have the same sign as b. So since we need to add to get a positive 3, our bigger number has to be positive. All right, let's look at another example. Number 7. We know we're going to have g something. We need to multiply to get a negative number. So we have to have different signs. We have to have a positive and a negative. So we want to find the factors of 6. So our only choices are 1 times 6 and 2 times 3. They need to have a difference of positive 1. So the only two terms with a difference of 1 are 2 and 3. If they need to have a difference of positive 1, then the larger number must be the positive term. So positive 3, negative 2. Now, I forgot to check number 5. So let's go back. Check. N times n is n squared. N times negative 3 is negative 3n. 6 times n is positive 6n. And 6 times negative 3 is negative 18. When we combine like terms, we get n squared plus 3n minus 18, which is what we started with. So this is our correct answer. Now let's check number 7. G times g is g squared. G times negative 2 is negative 2g. 3 times g is positive 3g. And 3 times negative 2 is negative 6. When we combine like terms, we get g squared plus g minus 6, which is what we started with, which means we did get the correct answer. All right, now for set 3. These have a minus sign and a minus sign. So let's just go with what we know. We know that we're going to have to set this up a something, a something. We know that if we multiply to get a negative number, then these have to be different signs. We have to have one positive and one negative. Now, we want factors of 3. The only factors of 3 are 1 and 3. So we have to ask ourselves, can we get a 2 out of 1 and 3? Remember that if we have different signs, we have to have a difference to equal 2. And so the difference of these numbers does equal 2. Specifically, we need it to equal negative 2. So the bigger number, 3, has to be negative. So 3 is going to go with the negative sign and 1 is going to go with the positive sign. So let's check our answer. A times a is a squared. A times negative 3 is negative 3a. 1 times a is 1a. And 1 times negative 3 is negative 3. When we simplify this, we'll get a squared minus 2a minus 3. That is what we started with, so this is the correct answer. Number 11, we're going to start with b something times b something. Multiplying to get a negative means we have to have one of each sign. The factors of 63 are 1 and 63, 3 and 21, because 2 does not go into 63. 4 does not go evenly, 5 does not go in evenly, 6 does not go in evenly, 7 times 9, 8 does not go in, and then 9 is already on our list. So that's all of the choices we have. Since we have different signs, we need the difference of our terms to be 2. So that's going to be 7 and 9. We want them to add to negative 2, so the larger number, 9, has to be the negative number. So negative 9, positive 7. Then we'll check our answer. B times b is b squared. B times negative 9 is negative 9b. 7 times b is positive 7b. And 7 times negative 9 is negative 63. When we combine like terms, we get b squared minus 2b minus 63, which is what we started with, which means this is the correct answer. And finally, set 4. Set 4 has a positive and a negative. So if we need to multiply, well, first, let's set this up. X something, okay? We need to multiply to get a positive number. So a positive times a positive equals a positive. But a positive plus a positive equals a positive. Now, a negative times a negative equals a positive, so that could work. A negative plus a negative equals a negative. So 2 negatives is what we're going to have to use. So we have minus and minus. Now remember, same signs mean we want the sum to be 11. So 24 has a lot of terms. 24 divided by 1 is 24. 24 divided by 2 is 12. 24 divided by 3 is 8. 24 divided by 4 is 6. 24 divided by 5 is not an even number. And 24 divided by 6 is already on our list, and so we're done. We need these two terms to have a sum of 11. So 3 and 8 have a sum of 11, and when we make them both negative, they have a sum of negative 11. So let's check our answer as always. X times x is x squared. X times negative 8 is negative 8x. Negative 3 times x is negative 3x, and negative 3 times negative 8 is positive 24. When we combine like terms, we get x squared minus 11x plus 24, which is what we started with, so this is the correct answer. Now, for the next one, number 15, we're going to set it up like we have already. Y something, Y something. And if you haven't recognized it, we've set up in patterns, so we can just know, honestly, from number 13, that this whole set number 4, is going to be minus, minus. And we want two numbers that when we multiply them, we get 72, and when we add them, we get 17. That's going to be 9 and 8. Since our signs are the same, the order of our terms does not matter. Let's check our answer. Y times y is y squared. Y times negative 8 is negative 8y. Negative 9 times y is negative 9y. And negative 9 times negative 8 is positive 72. When we combine like terms, we get y squared minus 17y plus 72, which is what we started with, which means we did, again, get the correct answer. So these are the last examples I'll do with you. These are examples that have a greatest common factor involved. So as you've probably noticed, greatest common factor is going to follow us through all the different types of factoring. You should always check to see if a greatest common factor can be taken out first before you begin factoring a problem. So on number 23, we compare our coefficients first, 4, 12, and 8. The biggest number that can be taken out of all three of those evenly is 4. Then we have k squared k, but no k here. That means we cannot take out a k. So when we take 4 out, we are left with k squared plus 3k plus 2. This is a trinomial where a equals 1. So now we know how to factor that. So we are going to have 4, and then we're going to set up our binomials. We'll have a k and a k. Now these are mixed practice, so you have to choose your signs every time. You can't just assume that they are one thing or another. We want to multiply to get a positive. Sorry, we're not factoring this. We don't care about that anymore. Positive. So we have to have the same signs, so it's either both positive or both negative. If they add to get a positive, it must be both positive. And we want two numbers that multiply to get 2 and add to get 3, and that's just going to be 2 and 1. Then when we check our answer, there are multiple ways you can do this. You can distribute the 4 first, which is what I'm going to do, and you only distribute it to the first one. So 4k plus 8, and then k plus 1. And then you FOIL or distribute these. 4k times k is 4k squared. 4k times 1 is positive 4k. 8 times k is positive 8k. And 8 times 1 is positive 8. When you combine these, you get 12k, and you'll see that that is what we started with. So we did get the correct answer. Now number 28. 5, 15, 140. The smallest number is 5. You always check to see if you can take the smallest number out before you do anything else. You can take a 5 out. So that's going to be our part of our greatest common factor. There's no x in this term, so we can't take an x out, but there is a y in every term. Y, y, y. They're all the same. They're all just one y, so we're just going to take y. When we take 5y out of every term, we're left with x squared minus 3x minus 28. So we're going to factor it like this. X. We need to multiply to get a negative, so we have to have different signs. We want to multiply to get 28, and since we have different signs, we want a difference of 3. So our numbers are going to be 7 and 4. If we need it to be a negative 3, the larger number, 7, has to be negative. So we have positive 4 and negative 7. Then we check our answer. The other way to check your answer, and we'll do it that way this time, is to keep the 5y on the outside and multiply your two binomials together to begin with. So x times x is x squared. X times negative 7 is negative 7x. 4 times x is positive 4x. And 4 times negative 7 is negative 28. I would combine like terms before distributing the 5y. So we still have 5y on the outside. X squared minus 3x minus 28. And then distribute the 5y to all three terms. So we get 5x squared y minus 3xy minus 28y. Oops, I apologize. Not 28y, but 140y. And I didn't change the 3 either. Wow. That's supposed to be 15. So make sure you're following the proper steps to check your answers so that you don't think you messed up when you really didn't. All right, but this is the correct answer. Thank you so much for watching today, and I hope you have a great day.